There is a mountain range 60 miles south of Tehran that the Iranian government spent 15 years turning into a secret. Not a political secret, not a diplomatic secret, a geological one. They didn't build a facility near the mountain. They built it inside it, carved the mountain hollow, buried the facility where no satellite could resolve it, where no penetrating weapon of the previous generation could reach it, and where no conventional airstrike could survive long enough to matter. They called it Fordow. And by every metric available to the engineers who designed it, by every simulation run by the planners who defended it, and by the declarations of the leadership who point to it as proof of national invulnerability, it was untouchable. To understand why the world believed that, you have to look at what surrounds it. Not a fence, a kill zone. Rings of Tor M1 point defense batteries on the ridge lines, each capable of engaging low-altitude aircraft and cruise missiles at ranges that give any incoming system less than 4 seconds to react. Behind those, S-300 PMU-2 systems positioned at overlapping angles so that any approach vector, from any compass heading, at any altitude below 60,000 feet, passes through at least 2 engagement envelopes simultaneously. The radar coverage extends outward for over 100 miles in every direction. It is not a picture. It is a wall, and beneath all of that, the facility itself. Fordow is a city under the earth, cut into the granite substrate of the Qom mountain range, at a depth that the engineers calculated would require a weapon not yet in any nation's inventory to breach. The primary centrifuge halls sit behind blast doors that weigh more than a naval destroyer's anchor chain. The ceiling above them is not concrete. It is rock, living, continuous, undisturbed granite bedrock, reinforced with steel injection grouting, layered with additional concrete caps. The engineers' calculations were conservative on purpose. The facility could withstand a direct hit from any weapon in every publicly acknowledged arsenal on Earth. Every weapon except one. And that weapon had never been used in combat. The decision to use it was not made in a single room on a single day. It was the product of 18 months of satellite passes, signals intercepts, and a slowly escalating diplomatic crisis that exhausted every other available instrument. When the order moved through the chain of command, it arrived at Whiteman Air Force Base in Missouri as a mission package so compartmentalized that fewer than 40 people in the entire U.S. government knew its full scope. The crews were briefed in a vault. They were shown the target, the weapon, and the flight time. They were not told what to expect if things went wrong at the back end, because the planners had already calculated that there would be no crew left to debrief. At 11:47 p.m., the first B-2 Spirit lifted off runway 19, left at Whiteman, climbing into overcast so heavy it vanished before clearing the perimeter lights. No ceremony, no formation, no chase planes, just the aircraft, the dark, and the radio silence that had already begun. A silence that would not break for 23 hours and 41 minutes. The pilot felt the gear retract and locked his jaw against the tension that comes not from fear, but from the specific weight of knowing. He had flown this aircraft for 9 years and trained for this mission category for 4. This was the first time all of it was real. The difference between simulation and reality, he would later note in a classified debrief, was not adrenaline. It was silence. Real silence had a texture the simulator never replicated. The mission commander occupied the right seat, the senior aviator responsible for systems management, threat assessment, and final weapons release authorization. His first task, once the aircraft reached cruise altitude, was to verify the data link, a single encrypted ping to the airborne command element orbiting over international waters 400 miles to the east. The ping returned clean. The data link was live. He noted the time, 12:03 a.m., and began the mental clock that would not stop until wheels touched concrete on the other side of the planet. The Atlantic crossing was a study in controlled endurance. The B-2 is not comfortable. It was designed to be invisible, lethal, and global, and those three requirements consumed every pound of available engineering budget, leaving nothing for the human beings inside it. The cockpit is narrow. The seats recline by a margin that could be generously described as nominal. The environmental system swings between too cold and too warm, with no stable middle point. The pilot rotated between flying the aircraft, monitoring systems, eating sealed ration packs with the mechanical discipline of a man who treats food as fuel, and performing the stretching routines that the flight surgeons mandated. Routines he had once considered excessive until hour 14 of a training sortie taught him what muscle atrophy at altitude actually felt like. The first aerial refueling rendezvous occurred at 3:22 a.m. over the mid-Atlantic. The KC-135 boom operator worked entirely from the infrared camera, following the B-2's faint thermal exhaust signature against the black ocean below. Connection was made on the third attempt. The second missed by 12 feet due to a wind shear event neither aircraft predicted. 18 minutes of fuel transfer. Then the tanker was gone, and the B-2 continued east, alone. The second refueling occurred at 9:51 a.m. over Central Asia. By this point, the mission commander had been awake for 22 hours. His hands were steady. His instrument scan was deliberate. But behind his eyes, the fatigue was accumulating, the way water accumulates behind a dam, invisibly and constantly, with a pressure only understood when the structure finally yields. He ran his cognitive checks and passed all of them, logging the results in the same steady handwriting he had used at mission start. He had no way of knowing each response had taken him 4 seconds longer than his established baseline. The threat environment began to assert itself at approximately 12:30 p.m. local time as the aircraft transited into the outer engagement range of Iranian early warning infrastructure. The B-2's passive defensive management system, a sensor suite that receives and classifies electromagnetic emissions without broadcasting a single return of its own, began logging radar signatures. Acquisition radars, long-range early warning systems spinning their antenna arrays in slow, confident sweeps, painting the sky with pulses that found nothing. Because the B-2 is not precisely invisible, no physical object can be truly invisible to electromagnetic energy. What it is indistinguishable from noise. Its radar cross-section, the measurement of how much energy a radar beam bounces back from an object, is so small that the returns it generates fall below the threshold that most search radars classify as a valid contact. They are logged as atmospheric clutter, as birds, as instrument artifacts, as nothing. The electronic warfare support for the penetration phase came from a different direction entirely. A pair of EA-18G Growlers operating from a carrier group positioned in the Gulf of Oman, flying a track that kept them in international airspace while their jamming systems reached 300 miles inland. The Growlers' ALQ-99 jamming pods generate enough directed radio frequency energy to saturate an entire radar frequency band across a geographic zone the size of a small country. The Iranian Tor M1 batteries in the outer ring lost their coherent picture at 1:47 p.m. Their operators saw their screens fill with white static, a phenomenon they had practiced against in exercises and had a protocol to manage. They switched to their backup frequencies. The Growlers had anticipated the backup frequencies. The signal's intelligence picture had mapped them months ago, and followed the switch within 8 seconds. The Iranian operators switched again. The Growlers were 4 seconds behind this time, Then 6 seconds, as the EW officer on the lead growler managed a system overheat warning on his port jamming pod that forced a partial power reduction. He made the call manually, cycling power between the port and starboard pods in alternating 3-second windows, maintaining 80% jamming effectiveness with equipment operating at 70% capacity. It was not in the manual. He did it anyway because the alternative was a hole in the electronic umbrella, and a hole was not acceptable. The hole appeared anyway, not from the growler's equipment failure, but from a source that no signals intelligence pass had flagged as significant. A single UHF early warning radar, an older system that the Iranian air defense network used as a tertiary backup, positioned on a ridgeline north of Qom, operated by a duty team that ran manual gain adjustments every 40 minutes as a matter of unit protocol rather than doctrinal requirement. The manual gain adjustment, a physical knob turned by a young radar operator, following a procedure inherited from his predecessor who had learned it from his, briefly shifted the radar's sensitivity profile outside the band that the growlers were saturating. In that window, 3 pulses of reflected energy registered on the scope. The operator stared at the return. It was at the edge of the noise floor. It was moving at a velocity inconsistent with any known commercial track. It was there for 3 sweeps and then gone. He reported it to his shift supervisor. The shift supervisor had been in Iranian air defense for 19 years. He had seen artifacts, ghosts, and equipment anomalies that had sent units scrambling for nothing 100 times. He looked at the logged return. He looked at the track projection his supervisor system generated from 3 data points. The track pointed southwest toward Qom. He picked up his direct line to the regional engagement controller and reported a possible contact. Track confidence low, recommend immediate sector alert. The regional engagement controller issued the sector alert at 1:59 p.m. 2 SA-20 batteries received launch authorization against the projected track. The missiles climbed within 90 seconds. The Growler EW officer saw the uplink frequency spike on his radar warning receiver, the distinctive signature of an active missile guidance data link going hot, and understood what had happened in the time it took him to exhale. He had one option: a targeted jamming burst on the specific uplink frequency, concentrated maximum power for as long as his overheating pod could sustain it. If it worked, the missile's data link would be severed and the weapons would go ballistic. If it didn't work, or if it worked only partially, the missiles would continue guiding. He had no time for a second assessment. He keyed the system and held the power setting at the red line of the overheat threshold for 11 continuous seconds. The port pod's thermal warning alarm sounded. He kept the power at red line. The uplink signature on his receiver cut out after 9 seconds. The 2 SA-20 missiles climbed to their apex and began to arc. Without data link correction, they were flying on inertia. They passed 4 miles behind the B-2's actual position, detonating their proximity fuses against empty atmosphere. The concussion was not felt by anyone. The B-2 was already past the engagement zone, but the alert was now active across the entire Iranian air defense network. At Mehrabad Air Force Base, 2 F-14 Tomcat interceptors, aircraft that had been flying for the Iranian Air Force since before the revolution, maintained by engineers who were performing miracles of improvisation to keep them airborne, were scrambled at 2:03 p.m. The pilots went to full afterburner on departure, climbing at maximum performance toward the sector where the anomalous return had been logged. They had no radar picture of the contact. They had a track projection from a 3-point return logged 11 minutes ago. They were flying on geometry and instinct, 2 ancient aircraft in a modern electromagnetic battlespace, pushing their aging airframes toward a threat that had already moved 30 miles past the last logged position. The mission commander saw the Tomcat tracks populate on his encrypted data link feed from the orbiting AWACS at 2:06 p.m. He ran the intercept geometry without speaking. One of the F-14S was on a vector that, if held for another 90 seconds, would place it within 4 miles of the B-2's current track. Not a radar contact, a visual range intercept, the only detection method that the B-2's stealth could not defeat. He did not touch the radio. He did not transmit. He made a single course input, 15 degrees left of track, descending 3,000 feet, reducing power on the port engine cluster to asymmetrize the thermal signature. The maneuver had no name in the flight manual. It was something that emerged from a decade of training distilled into a single decision made in 4 seconds. The F-14's projected intercept track moved aft, 3 miles aft, then 6. The Tomcat pilot, flying without radar guidance in airspace that was now electronically contested and radiologically uncertain, could not find what he was looking for in the dark. He held his heading for another 40 seconds, long enough that the AWACS track showed him passing directly through the B-2's former position, and then began a search pattern that was already 60 miles behind the target he would never see. The weapon's release point was designated at specific coordinates over the Comm mountain range. The B-2 crossed the IP, the initial point, the invisible line from which all weapon delivery geometry is calculated, at 2:12 a.m. local time. The mission commander ran the pre-release checklist with the focus of a man who has been moving toward this moment for 23 hours and 41 minutes. The targeting system updated its solution from the GPS constellation, confirming the aim point to within a circular error smaller than a dining room table. The pilot held wings level. The aircraft was at its most vulnerable now, committed to a specific heading, altitude, and airspeed for a release window that was non-negotiable. If any threat had been waiting at this point, the standing answer was to accept the consequence and complete the release anyway. That was what they had agreed to in the briefing vault at Whiteman, in a room where nobody spoke about the possibility of not coming home, because speaking it would have consumed the mental bandwidth needed to do the job. The bomb bay doors open at 2:14 a.m. The mechanism takes 1.8 seconds from command input to full open. In the cockpit, the sound is felt more than heard, a structural shudder that travels through the airframe like the aircraft itself is exhaling. The first GBU-57 Massive Ordnance Penetrator released from the forward station. The aircraft lurched upward as 15 tons of precision-guided physics separated from the weapons bay. A physical sensation that is unmistakable and momentarily disorienting even when expected. The pilot made the correction instinctively, holding attitude, eyes moving between the horizon reference and the release confirmation on the store's management display. Clean release. The first weapon was on its way. 4 seconds later, the second MOP released from the aft station. The aircraft lurched again. The bay doors cycled closed in 1.8 seconds. The weapons were gone. The mission was in its final phase. What happens when a GBU-57 strikes rock-reinforced concrete at terminal velocity is not an explosion in the conventional sense. It is a penetration event, a physics sequence that begins with the miraging steel nose cone contacting the surface material at a speed that the engineers calculate in meters per second, but that is more easily understood as fast enough that the reinforcing steel inside the concrete does not have time to stretch before it fails. The nose cone does not shatter. The nose cone drives forward, displacing material laterally, opening a channel. The body of the weapon follows the nose cone, still decelerating, still transferring kinetic energy into the rock. The first layers of rock and concrete give way not by being broken, but by being moved, the sheer inertial mass of the weapon pushing the material aside, the way a rail drives through soil. Deeper. The weapon's internal fusing system counts down based on deceleration measurements. It is looking for the specific deceleration signature that indicates it has reached the target depth, the point where the explosive yield will be maximized by the surrounding material acting as a tamper. The first MOP's fuse counted to its threshold. The tritonal explosive detonated. The shock wave did not travel upward through the mountain. The surrounding rock absorbed and reflected it inward and downward into the facility. The blast pressure that reached the centrifuge halls was not what structural engineers designed against when they calculated the facility's survivability. They designed against overpressure coming from above. A weapon bursting on the surface or in the upper rock layers. They did not design against a pressure wave originating inside the rock at the facility's own depth, transmitted through the same geological medium that was supposed to protect it. The blast doors flexed inward. The cooling water lines for the centrifuge arrays ruptured. The power distribution switchgear in the primary electrical vault shorted across 3 phases simultaneously. The centrifuges, thousands of precision machines spinning at velocities that would disintegrate any bearing system not built to exact tolerances, went out of balance in the same instant. The resulting mechanical cascade through the primary hall was total. The second MOP followed the cavity opened by the first. Its penetration was deeper. Its detonation reached the secondary enrichment hall, the backup array that had been installed specifically to ensure continuity of operations in a degraded scenario. The secondary hall's ceiling had been reinforced above its original specification after intelligence assessments in 2019 suggested that penetrating weapons technology was advancing faster than anticipated. The additional reinforcement did not change the outcome. It changed the detonation depth by a margin that the weapon's fusing system adjusted for automatically, as designed. At 2:15 a.m. local time, seismic monitoring stations registered a 2.8 magnitude event near Guam. The duty seismologist logged it as a minor tectonic event and continued his shift. At 2:26 a.m., the garrison commander attempted to reach the facility's underground command center on the primary landline. No connection. He tried the backup radio net. No response. He tried the emergency hardwired intercom. It was live. Nobody answered. At 2:32 a.m., he dispatched a security team into the primary access tunnel. At 2:41 a.m., the first team member returned to the surface entrance. He stood there for 30 seconds without speaking. When he spoke, he reported that the blast doors at the first checkpoint were intact. He reported that the blast doors at the second checkpoint were not intact. They were approximately 12 meters inside the tunnel from their installed position. He reported that the tunnel beyond was inaccessible. The garrison commander understood the implication of 12 meters of inward displacement for a door that weighed in excess of 200 tons. He picked up the secure line to Tehran. He had no words for what he was about to report. He used the words that existed. At 3:17 a.m. in a secure command facility outside Tehran, the information was confirmed. The Fordow fuel enrichment plant was rendered completely and irreversibly inoperable. Both primary and secondary enrichment halls had sustained total structural collapse. The cooling infrastructure was gone. The electrical distribution system was gone. The centrifuge arrays, representing decades of procurement and technical development, were gone. The garrison had followed evacuation protocols issued in 2018. The technical staff had been relocated to surface dormitories 4 hours before the strike window. Personnel casualties among the facility staff were limited, but there was no facility left for them to return to. The B-2 was already 400 miles from the target when the garrison commander picked up his secure line. The pilot had completed post-release checks and re-established the encrypted data link to the AWACS. The mission confirmation came through as a single coded character group. He acknowledged with a single coded character group. The aircraft turned onto its egress, heading at 2:19 a.m. Outside the cockpit, over the calm mountain range, the only visible sign of what had happened was a faint haze of disturbed dust, rising from a collapsed ventilation shaft, drifting southeast on the high-altitude wind. Invisible to radar, invisible to any satellite overhead, visible only to the mountain, and the mountain said nothing. The numbers? When the mission package was formally closed 24 hours and 9 minutes after takeoff, were these: 24 hours and 9 minutes in the air. 2 GBU-57 Massive Ordnance Penetrators employed. 60 meters of reinforced rock and concrete, breached on initial impact. 90 meters reached by the second weapon. 0 radar tracks confirmed by any element of the Iranian air defense network. 11 minutes elapsed before the garrison commander suspected something was wrong. 26 minutes before Tehran received the first report. 0 aircraft lost, 0 personnel from the strike package. The facility that was declared beyond the reach of any kinetic threat was no longer a facility. There is a specific kind of silence that follows a mission of this category. Not the silence of nothing happening, but the silence of something irreversible having happened. The engineers who built Fordow understood every threat that existed on the day they poured the first layer of reinforced concrete. They built against those threats with precision and with the specific confidence of people who had done the mathematics correctly. What they could not build against was the threat that did not yet exist when they began. The weapon that was already on the drawing board in a different country, in a different vault, designed specifically for the structure they were building. They were defending yesterday. The strike package was carrying tomorrow. The mountain remains. The fortress is gone. That is the difference between stone and will.